Next we have worksheet number 3. This is going over the nonspecific immunity. In the nonspecific immunity, basically you have your nonspecific immunity and your specific. Your nonspecific is something everyone has. Everyone has skin, everyone has mucosa membranes, everyone has white blood cells, everyone has a fever. Your specific immunity, though, is something different. Your specific immunity is like with the chicken pox, like we said earlier. The chicken pox, you get it one time and then you don't get it again because your body has learned to make defenses against chicken pox. So right now we're just going to be going over the non-specific, the non-adaptive, what you're born with. So the first portion, so what is in red is what you need to fill out on the worksheet or what you're expected to. So the first defense is known as species resistance. It is a second line of defense, and this depends on pH, temperature, and the chemical environment of a species. So this is like, I think it's with animals or like dogs, they have a higher temperature than we do. So our bacteria and our viruses that get us sick don't go to our dogs because our dogs have a higher temperature. Like they'll feel like they're burning. And they want our nice, what we got, right? So species resistance really just depends on the species. So species of human, species of dog, species of cat. This is a resistance that your species has over time developed, but if you're a human, you have human things. We all have a standard pH, a standard temperature, a standard chemical environment, and this differs from, felines, canines, us. The next one we have is phagocytosis. When we look at phagocytosis, let's do this. What is a phagocyte? Okay, site. Phago means to eat. So whenever I think of a phagocyte, I think of Pac-Man. It's just, and then like whenever I draw like pathogens, it's gonna be little ghosts. So that's that, yeah. So your phagocyte is like Pac-Man. I guess the P's kind of help with that. And phagocytes, these are a second line of defense, and these engulf, so engulf means to eat. These engulf and destroy cellular debris and pathogens. The main phagocytes are two different kinds of white blood cells, and this would be your monocytes and your neutrophils. So typically when you have like a bacterial infection, your neutrophils react first. Your neutrophils are there, and they're not very strong phagocytes. The more stronger ones are your monocytes. So your monocytes actually in your blood, monocytes are monocytes, monocytes are monocytes in your blood, but then when they go into your tissues, they become macrophages. And like when you break it down, macro means big, and phage means to eat. So your monocyte white blood cells become macrophages when they go into the tissues. So, which is nice, right? We want our monocytes to leave our bloodstream and go into our tissues to eat up any bacteria that's gotten into our tissues. So that's kind of nice. The next second line of defense we have is known as a fever. And the thing I would really take away from fever is that it utilizes interleukin-1. And interleukin-1 is classified as an endogenous pyrogen. So endogenous means inside. What does pyrogen mean? What is a pyrogen? Okay. Have you ever heard endogenous? Okay. Have you ever heard, so endogenous means inside. Pyro, though, means fire. Okay. So have you ever heard of like a pyromaniac? Maybe not. Basically, a pyromaniac is someone who is obsessed with catching things on fire. And it's, yeah, that's that. So pyro means fire when you break it down. So interleukin 1 is an endogenous pyrogen. Well, what does a fever feel like? It feels like you're burning up inside. So there's that. And fever just basically, elevates body temperature to inhibit. Inhibit also means to stop microbial growth. So if bacteria and viruses and pathogens like our temperature, that's fine and dandy. We like our temperature too. But in order to kill them, we have to burn them out. And we do that by having a fever. So yeah, interleukin 1 is what I take away from that. Next we have is a mechanical barrier. This is the first line of defense. This is the only first line of defense. If you notice in this chart, everything else is a second line of defense. A mechanical barrier is just that. It is a barrier. It is your skin, your hair, your mucus, and your gastric juice. Your skin, obviously, protects from infection. If you have a burn patient and their body is exposed, they are at high risk for infection. Hair, we have our eyelashes and our eyelids that kind of keep dust from getting into our eyes. Mucus, gastric juice, you have mucus in all your orifices except for probably your ears. But there's that. And then you have gastric juice. So basically what mucus does is whenever, just say I breathe in all these pathogens, and we do this every day, germs are everywhere. Those germs will then attach to your mucus, and you can either, blow it out in a hanky and toss it, or like a tissue or something. But with gastric juice, now what are those things inside your trachea that push mucus? What are those? Did you learn about those? Not muscle. No, they're like little hairs inside your trachea and your breathing. Cilia? Yeah. So basically, which is really cool, whenever you breathe in, the pathogens get stuck in your cilia, in the mucus of your breathing pathway, which is nice because then it doesn't go into the lungs. But then how your body gets rid of it is the cilia that lines your passages will kind of sweep that mucus up. And it sweeps it up the trachea and then puts it into your down your esophagus, so then you swallow, like when you swallow mucus, it's, that mucus has pathogens in it. So when you swallow that mucus, it goes to your stomach acid, and your stomach kind of like destroys anything that was in there. So gastric juice, mechanical barrier. Just something cool. I think it's pretty amazing. Next, second line of defense, and this is something a lot of people forget about. This is your natural killer cells. Natural killer cells, the big takeaway is that they secrete perforons. Perforons lyse cell membranes of viruses and cancer. So basically the way I like to think about natural killer cells is these are the ninjas of your body. And the perforons, the things that they secrete, are like ninja stars. So these ninja stars, or these perforons, kind of, the natural killer cells kind of throw them and they cut open viruses and cancer. So perforon, natural killer cell, if you know those key words, hopefully if you get a question about it, you'll be able to figure it out. But again, this is an innate immunity. Not everyone has this second line of defense. The next thing we have is inflammation. And inflammation is defined as redness, heat, and swelling and pain. This walls off the infection site and stops the spread of infection. So I'm going to draw kind of what inflammation looks like. So if you have, let's do this. If you have, this is your blood, right? And blood is flowing this way. Okay? Just say you get stabbed or something, you know, you get cut, it kind of damages this. This allows pathogens to get in. Right? So because blood is flowing this way, your body doesn't want it to spread. So it will pinch. It will wall off. That's what walling off is. It will kind of pinch this, pinch your vessel to prevent this pathogen from getting out. So one side of it kind of pinches, and the other side, though, kind of opens. So this portion of it will kind of get bigger because it's trying to increase the flow of white blood cells that are coming to eat the pathogen. So one side walls off, the other side opens up. So this is why you have, so let's look at the symptoms, okay? Redness. You're increasing blood flow. So because there's more blood flow, blood is red, redness. You got the heat because your blood carries heat. You have the swelling because when this kind of gets bigger, it causes swelling. And then pain. The pain from an infection, alongside your blood vessels, you have your nervous system. These are nerves that aren't here. This is dead. But you have your nervous system. So when this inflames, it kind of pushes up on those nerves. And when you have a pinched nerve, I mean, that's what's happening, and that's why you have pain. So this inflammation for you, it's more than just getting like a little cut. But basically, like I said, walls off infection and stops the spread. So it stops the spread and increases blood flow. Next, we have chemical barriers. This is the second line of defense. And at the end of this worksheet, we're going to go into each one of these more. But a chemical barrier would be your enzymes, your interferons, your defensins, collectins, and complement. And those are pretty much all listed there for you. But I believe it's this one. At the end of the worksheet, yeah, it has a matching thing at the end. So you could just match the definition with its function. So we talked about, phagocytosis. So we're going to be talking, which is right up here. We're going to be talking about macrophages. So three actions of macrophages. They have diapedesis, chemotaxis, and adhesion. So diapedesis, when you look at, I'm going to erase this. Ped. A lot of people think ped means like child, but diapedesis, ped actually means foot. So you hear like pedestrian. A pedestrian is someone who walks, one person who walks. So diapedesis is something macrophages do. Like we were talking about how the monocytes turned into macrophages. This is in your tissue. Monocytes are in your blood. So diapedesis is basically the ability of monocytes to step through the blood vessel and get into the tissue. So I'm going to pull up a picture of diapedesis really fast. So ped means foot, is basically stepping through. So diapedesis. And you get a lot of diapedesis with inflammation, but do you see how it kind of steps through? It's kind of like if I were to go into this corner and just kind of and slip out the other way. Kind of like, this is really gross, but kind of like how rats and cockroaches get through things. That's diapedesis. If their head can fit somewhere, then their whole body can, and it's disgusting. But But yeah, so diabetes. The next thing we have is chemotaxis. So basically, when I talk to you, so this is, let's see. So this is me, okay, and I'm communicating. I'm talking to you, and this goes to you. Okay, chemotaxis is communication. So basically, if I were an immune cell and I got hurt, I would say, ouch, pain. That's chemotaxis. Ouch. This, this poor little tissue that got hurt, this message, this communication, this chemotaxis would go to the macrophage, and the macrophage would be like, oh, there is pain there is damage there, we need to eat up anything that's like left over, like trash or things in the body that are destroyed, or even pathogens, because a lot of pathogens, bacteria, and viruses cause damage. So the damage causes your your cells to say ouch, and then your immune system or your macrophage receives this, and then it'll be like, how can I help you? So it's chemotaxis, the communication between cells. And macrophages are attracted to cytokines that are released by that. So chemotaxis, communication, and cytokines. Cytokines are the actual chemical, but it's there. The next thing we have is adhesion, and this one's the easiest one of all. So just say you get a nice, lovely bacteria in your body, and your macrophage is like, nope, you look like a tasty snack. Macrophages bind to the pathogen. They then clamp down, so Pac-Man's mouth is closed. They then surround the pathogen, engulf it, they eat it, and they digest it. So then it rips it apart. That's adhesion. So that's what your macrophages do. So the next thing we're going to go through is a fever, which is another second line of defense. And so with this one, basically in the parentheses, I think I put parentheses. I got to see what you're looking at. Yeah. So when someone is running a fever, their temperature increases and the spleen takes up iron. And the reason why your spleen takes iron is because the bacteria and the viruses live on iron. So your spleen, when you get an infection, your spleen is like, oh no, you ain't getting any of this. So the spleen kind of hoards all the iron to keep it away from the bacteria and the viruses and things. So overall, and that's what happens when you have a fever. So when your body gets hot, your spleen is like, oh no, I need to hoard this iron. So thus, or like overall, fever restricts the growth of pathogens, and it restricts the growth because it's taking all the iron away from them. And fever also promotes the activity of phagocytes. So not only are you burning the pathogens, not only you're taking away their iron, you are also your macrophages, they're like, ooh, it's hot in here. We need to go eat things now. This means there's an infection. So your phagocytes get really excited and they want to eat things. So yeah, that's that. That's what fever does overall. Next, we're going to be talking about pus and, well, mainly inflammation. Pus occurs with inflammation. We have that on the board where it's inflamed. Pus occurs with inflammation and is a combination or like a mixture of dead pathogens, like dead germs, damaged cells, because whenever you have an infection, you're always going to have something damaged. There's always, because that's what chemotaxis is saying, ouch, right? You're always going to have some form of damage. So the stuff that's ripped apart, taken apart, or damaged, that turns into pus, and then you can like pop it, which is so nice. And then it also has white blood cells. So the white blood cells that were there did the work, then they're gone. So that is with inflammation. Next, we're going to go over chemical barriers, and this is the matching portion of it. Let's start up here. So collectin. Yeah, we're going to do that. Okay. So collectins, it is this definition. The main takeaway with collectins is yeast. None of the other definitions has anything to do with yeast. So if you see yeast, it has to do with collectin. But anyway, collectins protect so this is a second line of defense. This is natural, innate immunity. Collectins protect against bacteria, yeast, and some viruses. These collectins adhere to them, so they kind of stick to them and makes them more susceptible to phagocytosis. So phagocytosis is the eating. So if you have a ghost, your collectins kind of like glue themselves to the surface, and they're like, you can't do anything, and it kind of slows them down, so that way they're more susceptible to phagocytosis. So that's what your collectins do. And how collectins know to attach is on the surface of bacteria. They have sugar molecules. So I don't know how in depth Mark will talk about it, but collectins are attracted to the sugar molecules. So that's that. Another type of chemical barrier has to do with enzymes, and this is a chemical barrier to pathogens. So even though gastric juice is classified as a mechanical barrier, it's also classified as a chemical barrier because it's gastric juice. That's the pepsin, that's the hormone in gastric juice. And then you also have, in your tears, you have lysosome, and lysosome is an enzyme. Next you have complement. And in one of the worksheets, we're going to go over complement here shortly after. It's a little out of order, but there's a worksheet that looks like this, and we're going to be talking about complement on this worksheet more in depth, but because everything connects. So, woohoo. So complement, basically, it stimulates inflammation. It causes inflammation to happen. Super important. Complement also attracts phagocytes, so it tells all the little Pac-Men in your body to come over and is like, time for supper, and come and eat this bacteria. And then complement also enhances phagocytosis. So it's really important. Next we have interferons, and I like to think of interferon as in like interfering. Interferons interfere with things. And more specifically, they interfere with viral replication. So in order for a virus to take over the body, how it works is it has to reproduce and kind of like form an army to attack the body. But if you have interferon in your body, it blocks viruses from replicating. It also acts against tumor growth. So with viral replication, right? We want to produce a lot, right? Because the more army troops we have, the more we can attack, you know? I don't know. But with tumors are kind of like the same kind of thing. So with a tumor, so this is like your normal cell, right? You have normal cells, but a tumor growth is multiple cells. So just like with the virus, you know, trying to enhance its troops, tumors grow and they don't stop growing, and they're just like a big mess. So interferon interferes with growth. It's interferons stop growth from happening. And then it also stimulates phagocytosis because it wants these little Pac-Men to eat the extra stuff. It's like, we don't want any of this. That's what interferon does, takes away the growth and stimulates phagocytosis. The next thing we have is defensins. And defensins are men with shields, defense, our main defense mechanisms. These are produced by neutrophils and other granulocytes. So you have, I believe in the blood system, there's a worksheet that there's a table of white blood cells. And you guys learn that there's granulocytes and agranulocytes. So what is the difference between granulocytes and agranulocytes that you know of? Agranulocytes? What is, like, if you look through a microscope, what is the difference? It's okay. So with granulocytes, so I'm going to pull up an old worksheet because a lot of this stuff kind of intertwines. It's anatomy. Let's go to blood. So granulocytes, when you look under a microscope, they look really grainy. They look like they have sand inside of them. And agranulocytes don't look like that. So looking at this from another thing, so you have your neutrophils. These are all your white blood cells. You have your neutrophils, which are granulocytes, your eosinophils, which are granulocytes, your basophils, which are granulocytes. And if you want this, I can send it to you too. Just saying. And then you have your monocytes and your lymphocytes. Interestingly enough, your monocytes and your lymphocytes are agranulocytes. So if you were to look at a microscope of a monocyte or a lymphocyte, which is like your B cells and your T cells, you would see that they were not grainy. So when I talk about granulocytes, I'm basically talking about just these top three. So in the question, or in the answer, cripples microbes, lyses cell membranes, that's what your defensins do. So they cut things open. And these defensins are produced by neutrophils and other granulocytes. So other granulocytes, which are like your basophils and your eosinophils. So a little bit of a long shot there. So that concludes the third worksheet. But I'm going to jump over to worksheet number 5 really fast and go over complement. And this is probably really difficult to learn too, because the immune system, you cannot see it. You can see a heart, you can see a liver, so a lot of this is going to be like very imaginative, and that can make it difficult. So this whole worksheet, this entire thing is dedicated to specific immune system, and this is an antigen, and this is just talking about what antibodies do. That's what the lightning bolts are. But basically, antibodies stimulate complement. So I decided to put different forms of complement enzyme. So complement is an enzyme that can do multiple things. Even though this is on the specific immunity worksheet, complement is innate. Everyone has complement. It's just certain people's immunity stimulates complement to work, and some of them don't. So does that kind of, okay. So we're going to go over this one really fast, over just the complement section, not the whole worksheet. We'll probably hit it up later today. What are we doing? Lymph and immune. So like I said, whole worksheet dedicated to specific immunity, but we're just going to focus on complement for now, which is just all this. See, so your specific immunity activates complement, but complement is innate. So this is part of your innate immunity. So your complement does agglutination, which is at the very bottom here. Agglutination kind of sounds like glue. It clumps antigens together. Oh, wait, do you have a matching thing on yours? I do not. Oh, wow, that was evil of me. Okay, I was supposed to have a matching thing. So agglutination, it clumps antigens by the complement enzyme. That is the agglutination. So it's clumping, it's gluing, agglutination, that's kind of what complement does. The next thing you have is lysis. And the way I like to think about lysis is to lyse something. Lyse, or L-I. Maybe I'll just say lysis, okay. So I like to think about lysis, slice. You know, it cuts things. So that's also what complement does, is it cuts things, it ruptures the membrane. So if this is the membrane of a foreign thing, like complement will cut it open. That's what lysis is. You have then opsonization, and this opsonization is the coating of antigen-antibody complex and making it more susceptible. So I like to think of opsonization as optimal. It's what you want it to be, perfectly, you know, whatever. So what opsonization, how complement does this, is you have a ghost, you know, you have a pathogen, and opsonization kind of forms, you know, a coating around it, so it kind of covers it, so it can't really do anything. And this just makes it more susceptible to phagocytosis, because I guess the way you can think about it, like it slows down it from moving. So that's what opsonization is. The next thing we have alteration, and alteration is known as, which one are you on? Are you still writing?
No.
Okay. Okay. So alteration is the changing of molecular structure by viruses to make them harmless. So the thing about viruses that makes them dangerous is, you know, if you look at like a battlefield full of people, their knives, their swords, their weapons, their bow and arrows, that's what makes them dangerous. But a person, a person or a virus is not too much of a threat, but they're the weapon they are, right? So alteration, how this enzyme goes along, and then it's kind of going along, I'll take that sword from you, I'll take that arrow from you, and I'm just going to take away all the things that make you dangerous, and you're just going to be just a virus without any defenses. That's what alteration does. It kind of alters the structure of the virus and takes away the things that makes it dangerous. The last thing we have is chemotaxis, and that's at the very top over here. And chemotaxis is basically what I drew up here with, with the two people. One of them says, ouch. This ouch is the chemotaxis. And one of them receives it, and it says, I'm coming to help you. What's up? And then it kind of like, I guess I'm going to give him a sword now because it's ready to attack whatever is hurting him. Because the chemotaxis is the communication. So there's that. Any questions on this, on any of these? Not really, just to read through it, yeah. Okay. Well, that concludes this session for now.